Greetings and welcome to ECE Design Team 2111's project. This is a joint project between the Electrical Engineering Department and the Mechanical Engineering Department. Our project is to modernize the media blast booth for the National Guard in Groton, Connecticut. The media blast booth uses highly pressurized hoses which blast the parts and hull of a helicopter with Type 8 plastic magic media. When blasted, the media strips the helicopters of paint, making them suitable for maintenance. The blast system was built in 1995. This means that it is over 25 years old and it has been used daily since then. The booth needs a complete renovation of all equipment and machinery. This is because it suffers from major issues including mechanical and electrical failure, media buildup, and a faulty ventilation system. The total scope of the project consists of replacing the current media blast system, designing a more efficient fuel collection system for the blast media, and fixing the blast room's airflow and ventilation. The sponsor has been very clear that it is mainly a design project. This means that our group will not be building anything but submitting designs for the new blasting system, the new media recovery system, and the new ventilation system. It is roughly estimated that the total project cost lies in the $3 to $5 million range. There are some main considerations that have to be met for the new blast system. The system must use Type 8 plastic magic media, be able to fit into the building's current blueprint, be made in the United States of America with readily available parts, and must comply with the National Fire Protection Agency and the National Electric Codes.
Due to the size and nature of these blasting booths, we needed to look at companies that already deal with the massive and complex machinery. To do this, we researched companies that have built similar systems for other military maintenance facilities. Talking and working with these companies has given us a good understanding of the different systems and which ones we recommend to the National Guard for their facility. Due to fire codes and a more powerful collection system being implemented, the new system will have to be rearranged within the building. The new layout of the subsystems has been analyzed and approved by a fire marshal. An additional reclaimer may be necessary to the new system as the floor collection system is being expanded. This image shows the new planned floor layout for all the subsystems. Another large part of this project is fixing the current ventilation system. Currently, the ventilation system has three main problems. The first is that the vents are manually operated. The second is that the room does not have the desired airflow. And the third is that the room does not always maintain negative pressure during operation. The National Guard wants the manually operated vents to be transitioned to an electromechanical system that can open and close the vent with a simple turn of a dial. To do this, we designed a system using a DC motor with a high torque and low RPM. Modeling this motor allows us to derive its transfer function. By itself, the DC motor is an unstable system. We can use unity feedback to stabilize this system, but the response is very slow. By adding a lead compensator to the system, we are able to achieve a stable and fast system response. Ultimately, this motor will be controlled by an Arduino that digitally controls the system using the Tustin equivalent of a lead compensator. This system provides adequate control for the DC motor. Another issue is the airflow of the room. During the winter, the top heating vents are used as intake vents to the room. In this mode, the air takes a desirable path through the room. But during the summer mode, the heating vents are closed off and the side vent is used. This creates an undesirable path for the airflow. To counteract this, we have considered the idea of implementing a vent into the ceiling of the room to get the desired airflow during both the summer and winter mode operations. The last issue is that the room does not maintain negative pressure during operation. This is very concerning as it is creating a safety hazard for the workers. After much analysis of this issue, we have derived the problem to be an old and worn out dust collector. The old dust collector is no longer able to keep up with the other ventilation systems, so the room ends up with positive pressure. Replacing the dust collector with a modern, more powerful unit would fix this problem, allowing the room to maintain negative pressure during operation.
Hi, we're Team ME15 and we were responsible for the redesign of the floor recollection system and filtration equipment. The current floor collection system has two small troughs that run along each side of the room marked in red. The main issue is that the system is inefficient and 50% of the operator's working time is required for cleanup of media after blasting. As the ME team, we worked on the filtration system and floor recollection design. A pneumatic system was chosen for the filtration system because it works well with the required media and provides the most efficiency, reliability, and applicability to our project. Our team decided that the 3x3 trough floor design, seen in the figure below, was the best design that fit the needs of the facility. It was designed by the original manufacturer, and our team is collaborating with ABS for equipment. The equipment layout plan is seen in the figure on the right, and it includes a standoff distance of at least 36 inches between equipment. The design was chosen because it fit the majority of the restrictions of the project, including Groton zoning, the high water table, FAR Part 77, and many others.
In conclusion, our team designed a new airflow and ventilation system, as well as designing a digitally controlled DC motor to operate the vents. The ME team was also able to design an improved floor recollection system and new layouts for the subsystems. As this semester comes to an end, our team will complete a briefing of the project to Major Holland and his colleagues at the National Guard. The project will then be handed off to professional engineers for full implementation. Thank you.